Second tutorial addressing the development on the HyperPET Pico. In this video we will learn how to use the graphical objects and graphical features of the system. And we will especially focus on the use of what is called sprites. As already explained, the Raspberry Pico supports 3 graphical layers, 2 background layers, L0, L1, that are tiles layers, typically made for your background of your games. So typically the things which are static, or the things, for example, that are part of a background scrolling or even parallax scrolling if you would use the 2 layers. And finally, there is a third layer which is meant to be used for sprites. Sprites which are the foreground objects of your games, like the characters, typically the things that move in front of everything. And sprites are typically objects that can be positioned at pixels levels and that can overlap each other. At the opposite of tiles, which are just a matrix of tiles, exactly like it would be on a wall. And they are, of course, tiles can be reused, so you can define a certain amount of tiles, and these tiles can be reused on the wall. But the tiles cannot overlap each other. I mean, one tile in one layer cannot overlap another tile of the same layer. They are typically next to each other. Sprites can be positioned wherever you want. So let's try to demonstrate this. So I will restart from the example that we had in the first tutorial where we were just waiting for a key. And the first thing we will do is just to set up the resolution to a lower resolution, because if you want to make typically games, and that's what we will try to do over here, if you want to make games, you will typically do it at a lower resolution than 80 columns. And there is one resolution that is not existing on the real PET, which is 256 by 200 pixels. It's a nice resolution because every coordinates of objects, for example sprites, will fit on 1 byte. So for programming, you don't have to take care about carry and report, and if you do an addition, etc., it will be quite simple to implement. So first thing we will do is to change the resolution, which currently 80 column, we will change it to this video mode. And for that, you can look in front, you have the set of registers, which are available on the HyperPET Pico system. You will see that the tiles map starts at this address, but that's not what we want. We will be interested in sprites, so there are 96 sprites. Every sprite has an index, which is just an index to the definition of the sprite. So you can define up to 64 sprites, and you can have on the screen up to 96 sprites. In fact, 16 per line maximum, but in total you can use 96. You see that you can, you have the index, but you also have the coordinate, the x coordinates. So because it's also made to be displayed at a high resolution, the x in 80 column can go up to 640. So that's why the x exists as a low and a high byte, but in our case we will switch to 256 by 200. So we will, in fact, we can set the xi to 0 at the beginning, and then finally the sprite y position. So you see you have actually every time a room for 128 values. Why? Because you have maximum 96 sprites, and I had the intention once to upgrade to 128. So everything is made like if you could use 128 sprite, but in practice you can only use 96. So we will first change the video mode. For that, so that's this register. And the resolution, we will change it to 256 by 200, so we will just write 2 into it. So if I go into the main program, I will first save the video mode, and I will push it to the stack, and then I will load the value 2, and I will store it into the video mode register. So we will basically switch to that resolution. At the end of the program, when we have pressed the key, I will restore everything, which means that I will just pull the old value from the stack, and I will also store. Yeah, seems I forgot something over here. And we will store it. Restore its value. So this will just change the resolution to the low resolution. So we'll just put change resolution to 256 by 200 pixels. We will also, another thing you need to know, that is that you need to enable the layers that you want to use. So we want to be sure that all the layers that we want to use, in our case, we are mostly interested by the layer 2 for the sprites, but we'll also enable the layers 0 and 1 for the future tutorial. So I will take this register. I will also, so we will need to set the bit 0, 1, 2. So I will also, before I will also load the old value, and I will also push it on the stack, and at the end I will also pull it from the stack, and I will restore it. So this is just to restore. I will call it graphics mode. And of course we still have to enable the 3 layers. So we will load into the accumulator. We will just load 1 plus 2 plus 4, which correspond to bit 0, 1 to 3 for layer 1 to 3. So layer 0, layer 1, layer 2. Which layer 2 is the one most important, that's for the sprites. And we will store this into the layer registers. So like that, we will just switch the graphics resolution to this, and we will enable the 3 layers. So we can compile the program, we'll save it. I will just go to that directory, src sample tutorial. I can recompile it, no error, and I can reconnect binary. You see that currently it's waiting for a key still. So I told you if you just type key after, it will just enter a key. So if we now run our program, voila, we switch to a lower resolution and we have our layers enabled, and it's still waiting for a key. So I can just send the key, and when we press the key, sometimes it doesn't send the key, it should restore the graphics mode, but it doesn't do it. Of course, stupid me. That's much better. Voila, switch back to what that was. So far we didn't do much. So I showed you the sprite registers, which were over there. So first things that we will do is initialize the sprite position and actually hide them from the screen. For that I have already prepared a small routine, which is this one. I call it hide sprites, and what it does, for each of the sprites, so it has a loop from 0 to sprite number of sprite maximum, which is 96. It will just load 0 and store them in the index of the sprite, the x low, x high, so the x coordinates, and it will move the sprite at the y coordinate outside the screen. So maximum we have 200 lines. So if you move the sprite y positions to 200, we will hide it basically. So this will just do this. I will just call it after I have initialized, and it will just basically hide the sprite. I will also call it at the end to be sure that when we leave the program that we have hidden the sprites. Now we need to program the sprites, because so far we just control the position, but there is no definition of any sprites. So to define a sprite, you need to use what is called the transfer registers set. So this is actually how it works. When you transfer a graphical object, for example, a sprite, you have to know that on the Raspberry Pico, all the graphical objects are stored as 1 byte per pixels. So 1 pixel is a value from 0 to 255. So this is how it is stored in the Pico itself. Now on the PET, if you would store everything as 1 byte per pixels, the things would take a lot of memory. So it is always possible when you transfer your objects from the PET to the Pico is that you specify them in a different format. So one of the registers, which is part of this set of transfer registers, is called the transfer depth. And you can define that every pixel of your graphical object is stored on 1 bit, 2 bits, 4 bits, or 8 bits. In 1 bit, basically, your object will have 2 colors, a background color and a foreground color. If you use 2 bits, then you can have up to 4, 1 background color and 3 foreground colors, etc. You can also, so when you use this specific indexed mode, then you also need to specify the color of each pixel. And for that, you use a lookup table, so a color lookup table, which will define for each of the values. So if you have, for example, the depth is 1 bit, for the background, you will have index 0 of the CLUT will define the color of the background, and the index 1 of the CLUT will define the foreground color. So if you, after you have defined the depth, you also need, of course, to define the color that you want to use in the lookup table. If it's 1 bit per pixel, you have to define 2 entries. Then you have to write a command. The command is just the type of things you want to transfer. In our case, we will transfer sprites, so we will use the command too. And together with the command, there are a bunch of parameters that you have to pass. And the bunch of parameters that you have to pass is the sprite number. So you can define up to 64 sprites in the memory of the Pico. And so every sprite has a number. You can define the width and the height of your sprite. I will come back to this. Normally the width in memory will always be maximum 16 pixels, and the height in memory will always be maximum 24 lines. So you have your sprites normally will be 16 by 24 pixels maximum. That is how it is stored in the memory. Now, if you want to create sprites which are smaller than that, you can specify a width and a height which is smaller than that. We'll come back to this. So these are the parameters that you have to send, the sprite number, the width, the height, and then finally you will pass the pixels of your sprites. So let's try to do that. I've created a small routine to do that. Yeah, and the data itself, so the pixels, you transfer them by writing to that data registers. So I made a small routine, and maybe as an example, The goal of this tutorial and the following video is to create a game, Space Invaders. So Space Invaders is a game from the 70s, one of the first video game. And the idea is that you have a ship at the bottom which can shoot bullets. And it is behind some bases, and you have an armada of aliens which is coming down. And this armada is typically going from left to right of the screen, and every time it reaches the right side, it goes down, etc. So it zigzag from top to bottom like this until all the aliens have landed on the base. Then it's the end of the game. And the goal, of course, is that the ship is shooting the aliens. So what we will do, we will restart from the graphics of that game. So I actually found a nice a nice website which show actually all the graphics which were used by that game. And in fact, we will use sprites to simulate all these aliens. So all the aliens which are here will be individual sprites. So there will be 11 by 5 rows of alien. You will have the ship, and you will have the bullets that you can fly. And we will support up to, actually the ship can only shoot one bullet at a time, so there will be one for the ship. And the aliens, we will reserve like 3 sprites for the bullets coming from the aliens. So the aliens are also shooting to the ship and destroy the base, of course. So we will reuse. In fact, that was on the arcade game that was actually using tiles for it. So what you can see is that all the different aliens, so if I take, for example, the ship itself here, you see that the ship is made of 2 small tiles of 8 by 8. But in our case, we will create it over a sprite, which will be, in fact, 16 pixels by 8. So forget about this tile map and let's just use the graphics which are there. So we will define our sprite. For that, we will use an array of byte. And we will use binary format because then we can represent the pixels. So if I want to make 16 by 8, so we'll make it 16 by 8 pixels. And the first one, we will just create a sprite which has 1, 2, 3, 4, 1, 2, 3, 4, and twice, so we will make it all zeros. And we will make it 8 lines. And we will call that the sprite empty. So we will use 1 bit per pixel, so every bit represents a pixel. Then we will create another sprite, and we will call it the sprite ship. And we will basically use this definition. So as you can see, it starts with a 1 over here, and then you have a 1, 1, 1, and then you have another 1, 1, 1, and then you have, so I'm looking at this one, then you have 5 pixels, and then you have at the other side 6 pixels, and then one more, and then the same actually for the remaining. So you get 4 times the same thing. So I can copy this, 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 and this. So this is the sprite definition of the ship. You see that it's actually starting with some zeros. So if we want to define actually the exact position, the exact width of the sprites, we should better shift this completely 2 pixels. So we can do that, but for the moment we will just keep it like that. And we will assume that the ship will be 16 pixels of width on 8 pixels high. So we will just transfer these 2 sprites. For that I created a small routine. In fact, it includes 2 routines, but if you want to define a sprite which is 16 by 8 by 1 bit, in this case 1 bit per color, you first have to define the CLUT that you want to use. So we will look at the lookup table register, so this one. And we will just store the color that we want. I didn't mention, but the color of a CLUT lookup table is actually always in RGB 332, which means you have 3 bits for red, 3 bits for green, and 2 bits for blue. So only actually 4 levels of blue. So if you want to make, for example, the ship being red, then you would just, in this case, write E0. So we will use black, which is all 0, and we will make the ship, let's make it red. So let's make it E0. So before we start transferring the sprite, after we have actually hidden the sprite, we can actually define the CLUT, and we will use red. We will store it as first color, and then we will use black. We will store it as first color, and the second color we will use red. So E0. Then we have defined the CLUT, and then we will invoke our small routine which will transfer 1 sprite. So the routine, how does it work? It defines the width. So the width is by default 16. And we first write the command to, which is transfer sprite. We write it into the command register. And then we assume that the X register contains the sprite ID. We will store it in the parameter. Then we take the width, which is 16. We will store it in as a second parameter. And finally, the height of the sprite, height, we also store in the parameter. And then what will follow are all the different bytes that represent the sprite definition. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have in total 16 bytes to transfer, so 2 times 8. So that's why we have a loop here, which will, in fact, we will load in the pair of register 54, 55 the address of the sprite, so in this case sprite empty. So we will load, and then we will transfer byte by byte 16 bytes. After we have, of course, transferred the parameters and the command. So we will do this. We will load our first sprite, which is all empty, but that doesn't matter. So I told you it has to be in 54, so LDA, first the low byte. So in Acme, if you want to address the low byte of an address, it's just smaller than. We will store it into 54. And the same, the high byte of the address of the sprite definition, we will store it in 55. Then we will call the function to store the sprite, but you saw that also in X we have to load the sprite ID. So yeah, the idea is that the first sprite you define should always be empty. So the sprite 0 will be empty, and that's the empty sprite that we program. So if I load here, I already forgot, the routine is using x, so we load x with 0, and then we can call our routine, which will by default transfer for a sprite of 16 by 8. So we have loaded the start address of the sprite. We say it's sprite 0. So here. And we call the transfer. We'll do the same for the next sprite, which is the ship. We call it sprite ship. And we will put it as ID 1. So if we compile this, we have actually two sprites defined, and the only one which is important is the sprite 1, which is the ship. So what we can do, we already have initialized the sprites, but they are not visible. So we can just use our registers and use, for example, the sprite 0 for the ship as a test. So we will take these registers over here. And what we will do, we will define the first sprite of the 96 sprites. We will define it as the ship. So we will say sprite index for the ship, it's 1. We will store as the first sprite. Then the high we don't have to touch because it's always 0. The x, let's say we put it at 0. So we will load with 0. So that's the x coordinate being 0. And then the y coordinate, for example, we will also put at 0 to start. So we just should position our sprite, which is the ship, at the 0, 0 coordinate. So let's try to see if this works. So we compile our example. There are some errors, of course. What did I do as mistake? 180. Of course, I forgot to store. This was my lookup table, so my two colors, background 0 and E0. I forgot to tell you, of course, that when you define a sprite, they are typically transparent on top of each other. So wherever you have, in fact, a pixel with a value 0, you will see through what is underneath. So if you have two sprites or a sprite on top of a tile where you have zeros as color, you will see through it. So if you define the color 0 in this case, because here every pixel is 0 or 1, which is an index to the lookup table. So that means the first pixel color in the CLUT, the first color in the CLUT should be 0, which means it will be transparent. So let's just see if this compile now. Okay, now you can put again that sk.prg. And we should normally see our sprites. We see something over here, which is not the sprites that we define. Let's move it slightly below, because otherwise we won't see. So let's move it to let's say, a different coordinate. And we will take, let's say, 8. Problem was, we forgot to define before we start transferring the sprite, we forgot to define actually that we were working in the 1 bit per pixel. So we have to define the depth being 1. So every pixel is 1 bit. Then 1 bit means 2 values. We can define the lookup tables for the background color and the foreground color. And then finally define our sprites and transfer them. So let's try to see if that now works. Ah, much better. Now we have our sprite, which is a red ship indeed over here. Okay, now that we have our sprite with the ship, let's try to organize a bit the code and trying to parameterize everything. So I cheated a little bit and I prepared some code that we will together assemble. So for the ship, I propose we define some macros to define the X and the Y positions. So at the level of the Y, the ship will always be at the bottom. So I look, of course, at the Space Invaders. The ship is always at the same height. So I propose we define the Y being the height of the screen being 200 minus 8, which is the height of the ship. And we will center the ship at the middle, meaning resolution horizontally is 256 minus 16, the width of the ship divided by 2. Then the ship will go from left to right, and it will bump at the left and at the right. So the position of the bump at the left will be 0, and the position of the, this is of course reversed. So left and at the right, it will be 255. And I propose for the example so far, I think we use the sprite 0 for the ship, but the proposal is that we will have the bullets, we will have the ship, and we will have the aliens. And it's always better to put the objects that are going to be important to test collision. So like the bullets, for example, the bullets will hit the Space Invaders, but they will also hit the ship. So every bullet, it's better to position them in a way that we use the sprites, the lowest sprites in the list. So when I'm talking about this, I'm not talking about the definition, I'm talking about the registers of the sprite. So the ship, we will have, I already told you, we will have 4 bullets. So I propose we put the ship at ID 4. And then we will have the parameters of the alien, which will start at ID 5. So the aliens already mentioned, they will be 11 by 6 rows. So the number of rows is 5, number of columns is 11. The distance between 2 aliens, I call it alien step X, so that I decide to make it 16. And the same for the Y, so the distance between 2 aliens vertically, I also define it as 16. The aliens, it's important to know that the aliens are coming down all grouped together. So the aliens will come always from top to bottom, and they will always move all together. So the idea is that we will actually offset the complete armada when we will move them, and they will always be relatively to each other at the same position. So they will come from the top, so we will define the topmost position being vertically 32, so they will start at 32, and when they will come down, they can come to a certain level, which will be in fact a maximum, and I expect they will go down 8 multiplied by 8 pixels. So that will be the lowest position vertically will be the bump down. So bump up the top and bump down the. And for the left and the right, they will always go from left to right. So the leftmost position will be 0. And the complete armada, you will hit the wall when this alien touch the wall, which means that the bump to the right will be 256 minus the amount of columns of alien multiplied by the step x. So the first alien I already indicate will be at position at ID 5, so that will be the sprite ID that we will use for it. So the ship will be at 4 and the first alien will start at 5. So far we only defined the ship sprite and this empty sprite. We also need to define all the other sprites. The sprites are over here. So we will have the aliens, which have every time 2 sprites. So this is the first alien, and when he's walking, he toggles between 2 different sprites. The same for this one, between this one and this one, that one and that one. Then we will also need the explosion of the alien, already will define that. And the ship I already also will define this flying saucer, which is here. And finally, we need the bullet, but the bullet, I will not use anything from here. We'll define it ourselves. So that's the sprites we need. And I already did for the chip. I will not redo it again. So I've cheated a bit and I have prepared the sprite definition for the various characters that we need. So sprite alien 1 is the first alien, 2 variants with the feet moving at the bottom or not. I will just cut this and I will move it together with the definition of our sprite, which was here. I'll just copy it over here. So again, it's every time the same, an array of byte defined in binary, and every pixel is actually a bit of that array. So here is all what we have. Then we will also have to define all these sprites. So I also cheated for that. I have copied already all the sprites. But what we will do is to create maybe a subroutine where we will program all the sprites. So I have already created a function called program sprite. We will move what we had so far over here, the definition of the sprites. I will copy it to that subroutine and we will invoke it from here. Program sprites. And we will put everything over here. So you see that we define it the transfer depth, the lookup table. Everything currently is red, but it doesn't matter too much. And then the first part was the empty sprite, the second the space invaders, and we will add, so we already defined the sprite ID. One will be the ship. So again, that sprite ID is the definition ID. It's not the sprite number that we will use, which we define in the macro above. So we'll copy all the rest of the sprite definition. And I will move it to that subroutine over here. Yeah, just a small remark is that all the sprites are in fact the same height, so 16 by 8, except the 2 bullets. 2 bullets, they will be in fact only 2 pixels wide. So if you look at the bullets, you see that there are ones only on the first 2 columns. So for this one, we need to define the sprite width. So the definition is always on 16 pixels width, but when we program the sprite, we have to define, in fact, the width being for the bullet being only 2 pixels. And that's why for these 2 sprites we actually call this routine here. And you see that we load the Y to 2. So by default, when we call the sprite 16 by 81 bit, the width is 16 pixels. But if we call the N by 8, then it expects the Y register to contain the width of the sprite. Okay, so far we have all the sprites and we have the definition of all these sprites, and we program them. Now we have to position them. And we will position them using some variables. I also prepared all this, so this was just some code I have. If you want to define the color of the sprite different, we will do it later. We will use this piece of code. I keep it there for the moment. But what I will also use is to define some variables. So some bytes that will contain, for example, the ship sprite X position, because the ship will go from left to right. We need a variable to store the X position of the ship. So I propose we use this variable for it. So what we will do at the beginning, if you remember well, we were hard coding, in fact, the position of our ship. That was here. So we currently position at the Y position being 8, but we define a variable that we called ship underscore and then ship Y. So we will use this. And for the X position, we will load the ship X and we will store it into the ship sprite X variable. And we will use the X position is this one. We will use here. We will load from so ship sprite X like this. And the sprite ID, we said we also have defined a variable for it that we called ship ID. So we will use sprite number 4 instead of sprite number 1. So that's what we have so far. So we position the ship at the bottom. Let's see how it goes. Let's try to compile all this. Sorry. Voila. So, you see, made a mistake because we probably took the wrong sprite over here. So we said that, that's not correct. Sorry, that's an error, of course. The ship ID, the sprite is still the sprite 0, but what we want is actually to use the sprite number 5. So it's here that we have to use ship ID. So in fact, every registers we have to index it by ship ID. So the sprite definition of the ship is still 1. That's our first sprite that we have defined here when we program the sprite. We first had the empty sprite being sprite ID 0. Then we have the ship, which is sprite 1. So our ship is sprite 1. So load the ship. So that's the ship sprite. Let's say try. Yeah, sorry, first I had to leave can do it once more. So now we have our ship at the bottom. So now let's position the sprites. For the sprites, we define some variables. So like we have for the ship, S for ship sprite X, we will define the alien sprite X positions. So again, they are 11 by 5 aliens. So the X will every time be 0 multiplied by alien step X. For the second one, it will be 1, etc. And then when you are at the second row, it will be again 0. So we just have all the X coordinates for every row of alien. So that's the first row, that's the second row, etc. So we have 5 rows. So it's just the alien step multiplied by the number being growing from 0 to 10 in that case. For the Y position, the same. So the alien sprite Y position, it will be the same, but this time in the Y order. So we will just have the first row will be at position 0 multiplied by Y step Y, which is 0. The second row, all the aliens will be at 1 multiplied by alien step Y, etc., etc., till the last one that will be at all the aliens will be at Y position being 4 multiplied by alien step Y. And for the sprite ID, the alien sprite, so the ship was at the sprite 1 and the first alien is at 2. So the sprite ID for the alien, all the aliens. So the first row, we will choose the first alien being the sprite ID 2. The two next row will be alien 4 and the last two rows will be alien 6. And now we have these variables. We need to program them. So for that, we will add the code underneath. We will have a loop. We will load the register X with 0. And then we will have a loop. And we will actually do the same as here. Except that the shipper will take it from the array. So we will load the sprite ID from alien sprite ID table, indexed by X. We will store it not at so in the sprite register, and we will index it by the first alien sprite, which is aliens ID, I think. Alien first ID, sorry. The same for this, the X position, the same for the Y position. And of course, we need also to index by X. And of course, here we need to take the alien sprite X, indexed by X. And these are just the variables we define underneath X. Then we will increment X. And we will compare X with the number of aliens, which is the number of row multiplied by the number of column. And if it's not equal, we loop. So let's review it. So this is for the aliens sprites. So we just program the sprites from the table. The ID, we take it from the table and we store it in the index register, also indexed by the first sprite ID, the X, the Y, increment, and we branch. Let's see what we have. So we should see the ship and we should see the aliens being at the top left corner. Let's see, let's hope it works. First we leave the previous program, now we run a new one, and voila, we have our sprites. We define them all red. If we want to change the color, we can always change the one. In fact, I told you we have two colors per sprite, so the background color and the foreground color. If you want to change the color of the sprites, it's quite easy. We will take this piece of code, we will move it here. So currently we define the color like this, but we can change that whenever we want. So for example, if we want the ship, suppose we want the ship being white, then we will take this and we will put it at the place. So now they are red, so we will put it here. So the empty sprite and the ship will be white. Then let's copy this. And for example, we want the alien being these colors. So we will have the first alien being yellow. We can do this. The second alien, we can make it cyan. And the last aliens, we will make it yellow. And finally, we have, that's the explosion. I think we will keep it also the same as the last alien. The saucer I will also not touch for the moment. For example, the bullet, we can make them red. We don't see it now, but like this. So now if I just recompile, the only difference is that we will have the aliens in a different colors. Voila, as simple as that. You see, by the way, that the text is still somewhere underneath the thing over here. We can keep it, but what we can also do, because by default we enable the 3 layers, but we didn't change what is actually in the layer. In the next tutorial we will start moving these aliens and play with the bullets to shoot and use sprite collision features to actually detect when the bullet touches an alien or the ship. So, but what we can do already now is that we will also use the tile layer in the layer 1. Currently the layer 1 contains the text, but you can also, by changing this register layer config, you can also specify what you see in the layer. So in this case, layer 1, if it's 0 we have the PET font, if it's 1. So if you program that bit to 1, then we will have the tiles, which by default are not defined, so it will be 0. So I will propose to do this as a last change. So this is 1, bit 1. Sorry, this is a bit with the value 1, 2, 4, 8, 16, 32. So if we add 32 to the sprite layer here, we will also should see the ties which are by default all 0. So as a last change, voila, we have our Space Invaders, all sprites being defined. That's it for this tutorial. Next video we will move all these objects and use sprite detection for it.